And then we say W equals minus P delta V. So we substitute that. Delta E equals Q minus P delta V. Now, remember, in here we can write delta E equals delta H minus P delta V. So let's say now let's compare delta H and so let's say if we have 2 moles of sodium and it reacts with 2 moles of H2O liquid, it gives 2 NaOH and H2 gas, and delta H equals negative 367.5 kilojoules per mole. Okay. Now, let's say we have delta H in here, 367.5. So if we say delta E equals minus 367.5 kilojoules per mole minus P delta V. In this one, it's, let's say, 1 atmosphere pressure given and V 24.5 liter. Then we can say it's about 24.5 atmosphere liter, and when you convert into kilojoules, 2.5 kilojoules. And then when you do that, 2.5 kilojoules per mole.
Did you get the liters?
And no, this will be given, it should be given with this equation. Okay? And then when you calculate, you get negative 370.0 kilojoules per mole. What we are doing, we are comparing. By doing this, we are comparing delta H and delta E. So that's kind of mathematical equations. We are going to work on one more problem quickly, and then we'll take a break. Calculate the change in internal energy when 2 moles of CO are converted to 2 moles of CO2 at 1 atmosphere and 25 degrees Celsius. Now this equation is given: 2CO gas, O2 gas, 2CO2 gas, and delta H equals negative 566 kilojoules per mole. This equation is given. Okay? Alright. So now, when we calculate delta N, means number of the moles, of product gas minus number of moles of reactant gas. So when you do that, you have that's 2 moles and that's total 3 moles. So 2 minus 3, you get minus 1. Alright. Now, we are going to use this equation, delta E equals delta H minus RT delta N. Why? Because remember, negative P delta V, we can write negative RT delta N. Instead of that, we can write ideal gas law, right? So now let's go to next slide. And we can calculate delta E equals delta H minus RT delta N. Delta H is given negative 566 kilojoules per mole minus R 8.314 joule per mole, and we convert 1 kilojoules to joules. Now, joules to kilojoules we convert. Temperature we have 298 Kelvin and delta N we have negative 1. Okay. So when you calculate, you get negative 563.5 kilojoules per mole. And that's how you calculate internal energy using their enthalpy.